Hi, everyone. This is Caroline Griffin with Riot. I'm very excited to have Chris Haire with BLDG-25 here with us today for our virtual Lunch and Learn session focused on why XR is the secret ingredient to Industry 4.0. Before we get started, I'll just go over some quick ground rules. One, the attendee list is hidden from all other attendees for privacy, but I guarantee you're not the only person here. Two, this session will be recorded and posted to Riot's YouTube channel and then shared on the meetup page, so you can find that later. And three, if you have any questions, please do put those in either the Q&A box or the chat box. Chris will be doing a semi-interactive session, so he'll be asking for some of your inputs. And then, as always, if you have any questions, we'll make sure to answer those at the end or during the presentation. So again, either the Q&A box or the chat box, and we'll be sure to get those answered. But without further ado, I will give it away to Chris, the reason why you're here today. Thanks so much for joining us.
All right. Thank you, Carolyn. And welcome, everybody. So like Carolyn said, there's one section where I may ask for some input from you guys as sort of a little bit of an icebreaker, and then we'll have some pause for questions later on. If I don't get to any of those questions, then I'll try to follow those up one-on-one with everybody. So we are here today to talk about why XR is the secret ingredient to Industry 4.0. And my name is Chris Haire. I'm SVP of Client Experience at BLDG-25. And today we're going to focus on how XR can help create better interfaces between people and the machines, or better connections with the digital technologies that we find in Industry 4.0, or what we might describe as the fourth industrial revolution. Many of you may be familiar with this term, or you may wonder what Industry 4.0 or XR means. So I'll run through that real quick. Industry 4.0, or Factory 4.0 as it's sometimes called, is utilizing key digitization technologies to increase the productivity gains from computerization of manufacturing, or what people refer to as digital transformation in industry and manufacturing. And XR is an umbrella term that encapsulates things like augmented reality, virtual reality, or mixed reality, and really everything that kind of falls in between those as that technology is becoming more and more widespread in our everyday lives. So let's talk a little bit more about Industry 4.0. And as I said, this fourth industrial revolution is going to rely on some key digitalization technologies. So when we say key digitalization technologies, what we're really talking about is things like big data, analytics, autonomous robotics, the Internet of Things, and sensor devices that are connected, AI, and additive manufacturing, or manufacturing that includes things like 3D printing or customization along the production line. And at some point in the future, we're going to likely see a convergence of what we now know as our smartphone, mobile VR headsets, and what you'll soon be seeing on the market, or have already seen, which is AR glasses. Those are all going to converge into some sort of, singular device, the dominant form factor. And that XR wearable has a lot of potential to become one of the next disruptive computing platforms. much like our smartphones did years ago and are currently today. So let's talk a little bit more in depth about XR and how it's used in this context of Industry 4.0. And when we say XR and Industry 4.0, we're talking about things like AR hardware being used by workers daily on the factory floor. We're talking about a combination of VR and AR for upskilling current workforces to the learnings they need to have to be successful in the new jobs of Industry 4.0. We're talking about AR being used to improve productivity in production lines or industry settings. AR being used in scenarios where there's inspection and maintenance going on. And you also see wide use of VR and AR and a bunch of rapid adoption in the product design space, as well as production design. So we'll talk a little bit more about that. For those of you that may or may not be familiar with some of these sub-terms like AR, VR, and MR, I'll run through some quick definitions of those. So augmented reality, or AR, is the layering of digital content onto physical reality. And that allows users to see at the same time through a smart display such as glasses or a headset or a mobile device, both the physical reality and the digital content on top of it. Virtual reality is a fully immersive but occluded experience in which the users interact with the digital objects and environments instead of the physical world. So if you've ever put on a VR headset or seen those big chunky things that make it look like people can't see out of them, that's exactly the point. They don't see the physical world. And then extended reality is, sorry, go back here. Extended reality is the spectrum that represents the blending of both physical and digital contexts. And it spans everything from augmented reality to one thing to virtual reality on the other. And generally, when you're hearing people talk about XR, even MR, they're talking about an experience that can occur on a variety of devices. So it might be a head-mounted display, it could be a PC, and it could be a mobile device in today's world. So one thing to be clear about these experiences is sort of how immersive they can feel. So I'd love for everybody in attendance to take a moment and think about an exciting application of XR that you recently experienced or that you've heard about that kind of caught your attention. And if you don't mind, maybe list those examples in the chat. And I'll pause here for a few minutes for those to come in. And then, Carolyn, I'm still not able to see the chat for whatever reason, so maybe you could read a few of those off to us as they come in.
Of course, yeah, there's some coming in already. Visiting national parks, with visiting in quotation.
Yeah.
And again, please put others in either the chat or Q&A box. Here's another one, heads-up display in car.
Mm-hmm.
GAF Viewmaster. Here's some more, knowledge transfer, remote assistance, document navigation, IoT data visualization.
Oh, cool.
Smart cities, directions, and spatial context. virtual user interfaces, Google Glass. These are really great, guys. Thanks for sharing.
Yeah, those are some excellent examples. And they really kind of span a wide gamut of use cases here. Everything from, you know, replacing distance with an experience. What did we also hear? Remote assistance and then data visualization. Those are some excellent relevant terms. I also, you know, people mentioned Google Glass, and while that product did come out and sort of go the way of the dinosaurs pretty quickly, it's about to be replaced quite widespread. There are about 4 or 5 companies that are going to be launching glasses, and a few that already have. And I don't know if you've seen any of these, but they actually look like reading glasses. You wouldn't know the difference to glance at them. And they're quite a bit more functional than some of the early Google Glass prototypes were. And even Apple's about to come out with one here in the next yearish time frame, from what I've heard. So, you know, those are wonderful examples. And I think what's important to consider about all of that is, you know, how XR allows us to sort of bridge some of the gaps that exist. And one of the big ones in Industry 4.0 is distance. Companies sometimes have few experts that they need to ship around to various locations to provide assistance to workers, and bringing people together that would have limited ability to meet or that could never meet is one of the key aspects of XR technologies. And I think that somebody mentioned, you know, learning. There were a few contexts there. And XR is really helpful when it comes to learning because of a few things. It gives learners a feeling of being in an experience, quite unlike nothing else can. And normally, you know, I think humans just react to that well in general, because we normally take in information from the physical world, which is 3D. And we're accustomed to several streams of input coming in at the same time, like touch, vision, hearing, and smell. And another big benefit is that it's much easier to learn something while you're experiencing it, instead of reading just a large block of text or looking at several diagrams to try to understand, say, a complex manufacturing process. Tools like VR and AR can allow you to be immediately immersed with the topic firsthand. And that allows learners to discover and work things out for themselves. And you also aren't limited by learning scenarios in tools like VR or AR, because there's no such thing as a scenario that's too dangerous for new learners to explore. It's safe. So I think, you know, the key thing here is that XR lets people learn and experience things through doing, and that often reduces the amount of time it takes people to learn new things, while also increasing their retention of that knowledge. So ultimately, immersive experiences are going to become more commonplace, and they're going to be very important in solving some of the challenges that Industry 4.0 currently is going through. So let's talk about some of those. Well, why, you know, do we care about XR and Industry 4.0? So some of the changes that are involved with this digital transformation in the current industrial revolution involve the workforce. And if anybody knows anything about digital transformation or industry, they'll probably tell you that people are very important and their skills essentially are more important than ever before today. There's a recent survey from Accenture that says, 80% of executives across enterprise agree that XR is going to be extremely important to leverage, and these immersive technologies are going to be very important when engaging with employees. People these days need to manage even more complex sets of manufacturing technologies and processes, and it presents new challenges for onboarding and training in that space. Boeing recently used AR in some training for one of their assembly facilities, and the workers that were trained using the AR methods were able to complete the work in 35% less time than trainees that were using their traditional drawings and documentation. And so there's excellent use cases out there and research being done on the effectiveness of this, not only in Industry 4.0, but generally across the board. Another thing that's important to consider is these sectors are becoming more and more digitized, and everything is connected and producing more data. Things like AI are helping by delivering insights. And XR can act as a missing piece here. It can bring, real people and their expertise into this equation, because while it's helpful for AI to provide us with some insights to make choices around, often these choices still rely on a human factor, and they probably should at the moment. And so in XR, that human-machine collaboration really optimizes productivity, and it can help minimize costly mistakes. There was an ABI research study that they found that using AR in the utility market maintained employee safety and also added to a decline in errors and total downtime in that sector. So AR is helpful from a safety perspective, and it also can help bridge the gap between some of these human and computer machine interfaces. And we do have a gap between this human-machine convergence in modern industry. Some of the problems that we see there are reduced worker attention and productivity as they have to focus on more complex processes and data, increased downtime and safety issues on production lines, because production lines are running shorter, faster, and they're becoming more customized. And without the ability to make real-time decisions with all this complexity, companies are finding it harder to compete in horizontal market changes that are occurring. So the workforce itself, of course, is also cognizant. They see this technology entering their workplace, and there are fears around, job loss and whether or not I'll be able to keep up with these new modalities. And so that can cause issues just as a personnel factor for companies that are trying to go through this digital transformation or in the midst of it. But there's good news there, because a lot of these fears that workforces have are proven to be unfounded, because AR and VR are becoming more integrated, and they're being used to not only show people how it can make their jobs easier, but also upskill them and train them in the new skill sets they need. And while it may seem counterintuitive, there's examples where we see both younger workforce and older workforce embracing the technology once they see, that it's not a factor that's going to eliminate their job, but it might actually help improve it. And for the younger workforce, it can help them receive information from older employees that have more knowledge and experience around some of the actual technical side of manufacturing or production lines. So a digital skills gap is also slowing the progress of Industry 4.0. Deloitte Manufacturing Institute recently ran a study, and they suggest that we're entering a period of acute long-term labor shortages for industry, and there's going to be projected shortfall of about 2.4 million job openings that will remain unfulfilled by 2028. And 36% of the companies they surveyed also cited, technical skills gaps or preventing them from benefiting from their investments in these digital technologies. And so another area that's critical for Industry 4.0 to improve in is product design and production design and visualization. As we all know, products are ever increasing in complexity, and the ecosystems in which they're developed are also increasing in complexity. So they are going to have to adapt to new ways of working. Designers and engineers both need to be more mobile. They have to be able to utilize insights from visualization tools, and they need to communicate design intent across dispersed groups, and they need to do that more securely. And so that's why XR can be the secret ingredient, because it opens a new dimension of work. Many types of information are going to become available to workers in a compelling and more easy to understand way. And companies need to evaluate the many ways that work processes can be reinvented by mixing and matching physical and digital components to bring together the best of both worlds. So let's talk about some of the common issues that we've seen being solved by using XR. So while extended reality has the potential to empower employees and transform operations and better serve customers, it also has some challenges like finding the ideal ways to create and present immersive experiences. And generally speaking, developing these applications is more difficult than developing most other types of enterprise applications. But that doesn't mean they don't provide long-term value that makes that extra cost and time worth it. So specifically, this need to merge digital, physical, and human elements to change industrial process is difficult, but it's essential. And a key area there is efficiency. Oftentimes, workers in current industrial situations need data to make decisions, but they have to often leave the floor, go to a back office, or go to some sort of repository of information to look up data about a specific tool, piece of equipment, process step in order to diagnose and make a decision. So with the ability to have a head-mounted display, which can look much like somebody had mentioned Google Glass, sort of a headset that has a piece of glass that can be flipped up or down and not only takes voice input, but displays data in an augmented fashion over that physical world. And it also leaves these workers that are making real-time decisions hands-free. You know, they do not need to touch the device or operate a tablet or a phone with their hands while getting this data. And so it does make them much more efficient. At the same time, because of the hands-free nature, safety is often improved. So viewing data in other factors like a tablet or a phone, you know, they compromise your situational awareness to some degree. Workers often have to reduce attention because they need to physically interact with a machine interface on a machine. And that, of course, leads to safety concerns because of attention. And a lot of times, some of the machines in factory floors have really archaic user interfaces. So navigating through these interfaces to get to the information you need can severely affect productivity. And oftentimes these machines with built-in interfaces can be some of the most expensive machines in the production process. Not only are they the most costly if they go down, but they're also expensive to implement and put into place. So a lot of manufacturers are looking to machines that can provide an Internet of Things stream of data up to a cloud and then deliver that to workers through head-mounted displays or other XR wearables. And agility is another area where manufacturing is seeing improvements via XR. Modern manufacturing currently today has frequent customizations where workers need to visualize machine statuses in real time. And that allows them to do things like prioritize their workload or anticipate tooling and material requirements for an individual task that's happening in a production line. So companies require new ways to increase their competitiveness that don't rely on mere production scale. Humans need to be better integrated into these manufacturing processes, especially where customization levels or volume of production change in relatively short intervals, which is becoming more and more common in the modern factory. So another big area of problem is this digital skills gap we talked about. It can be a significant barrier to success for a factory going through a digital transformation. 76% of workers are lacking the skills needed for new jobs in Industry 4.0. And you know, as we'll talk about some more, XR can be essential to solving that skills gap, as well as, you know, getting Gen X and millennial workers closer together in their knowledge bases. Training your current employees, or upskilling, as it's often called, is supported. And oftentimes, areas like data science, connectivity, cybersecurity, digital dexterity, these are the key areas that Industry 4.0 companies are finding they need to upskill current workers in. So it's not necessarily even manufacturing techniques or processes that this gap exists in. It can be more like digital dexterity, or this ability to leverage existing and emerging technologies for, practical business outcomes. As we said, more and more data, more and more decision making. And then we talked about product design and delivery and them adapting to this new paradigm. So this days of one person at a desk working on an idea in isolation is now, a rare occurrence across all enterprises. Today's products are developed by cross-disciplinary teams, and these teams are often cross-border teams. And they're collecting data from a wide variety of sources to use in the product research and design. And then also in the field, researchers are observing product use, and they're inputting information using pin-based computers or wearables to record conversations. And service engineers are often acquiring data from products that are already in work on a production line, and then they're using that data in enhancing product features or designing new products. And as we said, designers and engineers are also making complex decisions, and visualization and simulation really help there, because you have development teams that need to function both efficiently while being mobile, while visiting customers or locations, while presenting to management across the globe, or working with cross-border supply chains where they need to tweak tooling or resolve assembly issues literally from the shop floor. And as we talked about before, XR can help bring people to a location without them having to physically travel there. Remote assistance or remote viewing through XR wearables is becoming more and more commonplace and is used in various situations around the world. And then on the pure design side, visual computing and simulations are helping improve decisions and accelerate concept generation before new products hit a manufacturing or production line, allowing them to work out flaws or issues before, that becomes an issue with real equipment and real people. And then versioning and security are becoming more and more important. Teams are having to synchronize multiple data sets or rework modifications that may have been made on out-of-date versions of products or data. And it's particularly important during conceptual phases when designs are changing at a very frenetic pace and through many iterations. It's also common for these teams to be working in different time zones. So capturing design intent and then spreading it across these dispersed groups securely is becoming more common and more needed. And of course, closed system designs like VR and AR can aid in both that complex data set and having group discussions about data visualizations. All right, that's a lot. So I thought I might pause and maybe ask if you guys have any questions so far.
Thanks, Chris. We do have some questions here. Let me get these pulled up. Okay, here's one. Have you heard about Bostrom, Musk, Tegmark, etc. talk about achieving superhuman ability through augmentation that has occurred even with just today's smartphone? And how will XR alter that and further extend us?
Superhuman ability. Sure. I think some specific ways in which XR might extend or support that in the future definitely come around concepts of, speed to value. When we talk about superhumans, this ability, let's say, to be able to make better decisions faster is becoming more apparent. And of course, really that human element of decision making, even when presented with potential options through something like artificial intelligence, is essentially critical to large data systems. So in order for humans to make those decisions, they need to have more knowledge that's practice based, and they need to acquire that knowledge faster. And as we talked about earlier, AR, VR learning environments, there's tons of data out there about how rich and effective they can be for all learners. And I think in some ways, superhuman in the future means more people are actually retaining more knowledge more often. Of course, there are human machine interfaces where XR and AR may come into play, and those could include things like augmenting our physical abilities. If you've seen any of the work that's going into biomechanic sort of frames that people with disabilities might wear, or soldiers in a war zone, or people exploring a disaster area might use to enhance their physical ability, those no doubt will have a human machine interface that is controlled with some sort of XR wearable. And some of them already do as well. So I don't know if that's a good answer, but.
That's great. Thank you so much, Chris. I have a couple more questions here. This one is from Andrew. Andrew says, hands down, the best use of VR he's seen is specular theory's perspective, which puts the user in the shoes of being abused by the police. They are located in Venice, California, so they have access to the film industry. Do you believe there is a greater partnership in the triangle to be had between XR and one of our pillar industries?
Yeah, absolutely. So a hotbed of companies in the United States that I know of right now, where specifically this idea of design agencies which combine, top talents in the film and 3D content industry with the idea of new XR applications is Austin, Texas. If you look around that area, there are, 20-ish companies that are on the cutting edge, and there's probably another 30 that are working in specific film, video, 3D content roles, and they are all in one way or another, working on XR applications or want to do more of that. So I certainly see that in this area, we used to have a lot more film done down in the Wilmington area, but I see the future potentially being pretty bright for RTP because the access to technology to create great looking film and or 3D or visual effects is the bar has been lowered dramatically over the last 10 years, both in the forms of affordability and the interface and post-production. So those can be very critical to learning experiences like the one you mentioned, where people are put in this scenario and can learn from various outcomes on either side very effectively, changing their behaviors and doing so in a safe way.
Thanks, Chris. One more question here. How feasible is it to use XR technology in low data bandwidth or even disconnected mode?
It depends, I would say.
And if it's helpful, Chris, they do say use case maintenance / repair. Thanks, Sadie, for that.
Right. So when we think about applications for XR products, of course, data source is one of the key criteria that is involved in producing that end application. So data is often, completely custom built. If you think of a game like Pokemon Go, right, that's an AR experience, and their data set is built from the ground up purposely for just that experience. And it can work sort of in a limited data function or offline. And then you have data sets where you may take, for example, manufacturing diagrams or process step data, and you repurpose it for the AR, VR application. Those can also run in offline modes or low data transport modes because the data itself isn't changing often. And so updates could occur offline or when you had better data connectivity, but you still have a pretty decent up-to-date set of data to be used in maintenance check line or quality checks or, other things. Now, in cases where the data that you need to analyze is coming off of a machine in action, well, of course, that's going to be real-time data. And in those scenarios, data connectivity is a requirement. And that's one of the big stopping or slowdowns for wide adoption of AR and XR wearables across just the public sector. It's this data stream that 5G is promising us is on the horizon. When that data availability and bandwidth is widespread and also just faster than current bandwidth generally is, you're going to see a rapid uptake in all sectors of this sort of technology. At least that's what I think. So hopefully that was a helpful answer.
Thanks so much, Chris.
All right. We'll take some more questions for sure. And then if we don't get to any at the end, like I said, I'll reach out one-on-one to you guys to try to help. So I think we've got about 15 minutes here. I'll blaze through some more of these slides and we'll talk about some of the practical applications or the actual use cases that are currently being seen by us across Industry 4.0. We said merging this digital and physical elements is important, but challenging, and the digital skills gap is a significant barrier for success, and that product design and delivery need to adapt to this new paradigm. So how is convergence of physical and digital experiences becoming a feature of the modern factory? One thing is companies are exploring many XR capabilities that replicate and enhance life, including simulations or overlaying data on physical objects. And they're also enhancing virtual communication methods. New levels of safety are being achieved, which is often far more important than efficiency ever will be. Machine operators can benefit, for example, by receiving physical feedback from haptic technologies. And so that includes lightweight gloves that you might wear on your hands that impart some sort of feedback that's physical, that lets you either note things like danger alerts and or feel physical resistance. And head-mounted displays or AR glasses are becoming very common. And as we said, they allow you to free up the hands of your workers so they're focusing on their primary task while also getting visual and audio feedback from the headset itself, as well as the ability to use voice commands to ask questions or navigate through those data sets and call people in remotely for assistance or to deliver updates and statuses. So all of that is a promise that is sort of delivering some of that superhuman ability for industry workers. As we said, remote collaboration and analysis supports more efficiency, and it also makes these real-time decisions across complex data sets possible. So off-site specialists can be called in to consult or guide a technician through a task that normally might require that expert to come. If there's some sort of failure that's outside the normal working parameters or documented steps, these experts often have to fly to a location to get a production line back up and running. So with remote collaboration, that's no longer necessary. And managers that are on factory floors are able to survey status of all operations inside of a given plant or facility simply by maybe looking out across the plant and seeing augmented pop-ups occur wherever there might be issues, in addition to alerts that were coming in through visual and audio streams of information. Some other areas with hands-free solutions with things like data assistance or digital workflows and visual assistance as well. These are already being used within, Industry 4.0. When I say visual assistance, this is an area that's kind of interesting. Often when doing servicing or repair, you might need data provided to help you with diagram steps or part lists. But when doing testing and inspection operations, often there's a requirement for logging for compliance purposes. And a lot of these new AR wearables that you're seeing on the factory floor help technicians in this way. They can simply say, snap a picture in their wearable, which was also providing them with their compliance checklist, logs that test or the visual inspection data into the compliance system at the moment that the inspector is there. Obviously, maintenance and repair is an area where data assistance is very helpful, and or digital workflows can help walk people through the correct set of steps, because oftentimes these lists of steps are becoming too complex for humans to remember all the steps all the time. And then QR codes are being used, which is sort of an old or simple type of marker for AR technology. And that's a cue to the application that a specific object is something you should track or display data about. So that allows technicians to walk through a factory and just look at a piece of equipment, scan the QR code, and pull up data about that object in context. And that can be very, very helpful as well. All hands-free. So these headsets enable digital workflows to reach workers when and where they need it. They improve productivity and they reduce operational errors. And, you know, as we said, digital workflow solutions with visual instructions, checklists, data entry, and documentation is important, and that helps drive compliance. Things like visual assistance or voice-driven data entry. Make sure that you're capturing the right data at the right time and people are logging steps and tasks more effectively and more robustly. And work instructions also help people stay on track and follow along while performing work. And that has shown reduced errors and increased quality in end products for Industry 4.0. And as we said, these immersive learning deliver superior training experiences. They're better at emphasizing things through visualization, and they can provide environments that mimic real-life situations. And employees can gain greater levels of expertise in less time. And that's critical for helping to bridge the skills gap. And XR is helping bring about the end of distance and reduce costs for training. So being able to tap into any of the experts in your global company around the world anytime is incredibly valuable. And of course, not just moving people around in a travel way, but often training on large equipment requires people be brought to the equipment or the equipment setup be brought to people. And those costs can be massive for companies that do a lot of equipment training. And then we talked some about learning scenarios, and we had a question specifically about this. And I think these are some of the most interesting ways that XR might be used that you might not just think of out of the box. For example, you know, being able to practice communication and reduce negative behaviors in scenarios that are inherently dangerous. Walmart uses VR to train employees for Black Friday and actually simulate, you know, a mob coming into the store. And then they're trained on how to react to that to keep, you know, employees and customers safe. And of course, there's no loss of equipment or cost or a danger to the employees in those training scenarios, and they can fail in a safe way. And then VR is used extensively in heavy equipment training, like large crane training, where literally too expensive to ship the crane around, so people have to go to it, and then actually training in dangerous scenarios with large equipment can just be too much of a safety risk for a company. So it allows people to not only train up, but it also allows companies in the selection of equipment operators to sort of see what their ability might be before hiring them and putting them on the equipment in the field. And then also XR in product design and delivery is important. It's going to allow designs to be experienced at a human scale long before they're built. And it helps with generating new ideas and more informed decisions at earlier stages of development. So you're seeing this happen more and more, not only with products that companies make, but also the production lines that make those products. So for example, XR can be used in simulating a factory floor layout. Where would equipment be positioned? And the technicians that design these layouts can walk around in them and test whether or not there's going to be enough clearance for automated robotic carts and or human-driven machines that must traverse the factory floor and the layout. Philips is using this technology to automate assembly and plan 3D printing. They make digital twins, and they're using XR to drive robots and to visualize big data. And they're seeing, great strides in producing the first time right design and what is often referred to as zero defect manufacturing. So you're seeing a lot of this happen in Germany right now and in the Netherlands. So augmented reality also can sort of support this visual pipeline between designers and customers. And John Deere did a big test where they provided feedback from customers on early designs. And because of that work, their estimates are that VR simulations in designing air handling subsystems on one of their giant harvester combines could reduce design cycle times from 27 months to 9 months. And that's a savings of, hundreds of thousands of dollars for them. And customization and faster prototyping save time down the road for manufacturers. So like we said, more efficient line layouts being designed ahead of time, allowing additive manufacturing techniques, and prototyping how those might affect a production line. And then Caterpillar has been training some of its engineers at its own AM factory, where they learn how to apply 3D printing to new products, supply chains, and operations. And they even use this technology to help them design and then print parts for manufacturing equipment on the fly using additive manufacturing techniques. So certainly customization and faster prototyping is key. And then to summarize, XR is the key to transforming Industry 4.0. It's already being used to augment the way people work and improve collaboration. It's a transformative technology, and it's making people more collaborative. It's making manufacturing safer and more efficient. And considering how new it is, it's not really a bad start for XR. And it should be interesting to sort of see where new innovations there drive Industry 4.0. And as we see this dominant wearable design emerge, much like the iPod or the iPhone, we should see a lot more evolution within the space. So does anybody have any last minute questions? I think I may have time for maybe one or two before we have to close out the session, Carolyn.
Yeah, I see one question here, Chris. Do you discount the increase in memory storage capacity of devices, enlarging the ability of XR without increasing need for new communication bandwidth?
No, I think I'm not sure it's that Moore's law, but anyway, these laws of increasing capacity are key to remember when you think about digital transformation. I think they all support different modalities of delivery in different ways. And so currently still the idea of faster processors that are lighter weight, more memory capacity and battery length, those are key to the wearables that are currently being used on factory floors. However, as technology like 5G starts to extend the capability and reach of data and increase bandwidth for data, you will see that maybe hardware doesn't need to be as robust. And considering multiple laws around the expandable nature of both data, processing speed, and memory, all those together are needed in this coming convergence to that ultimate sort of XR wearable that will become the dominant form factor. Those will all be components of it.
Thank you so much, Chris. Well, thank you all for joining us today. If you have additional questions, I encourage you to reach out to Chris directly. We'll make sure you have his contact information. As always, you can reach out to me and I will connect you. Thanks so much. Everyone have a great day.
Yeah, thanks for everybody's time.